So to determine the classification of this equation, we need first to identify the order, the degree, and the linearity of this equation. So first, to do that, the order of this equation is it's only a first derivative, so it is 1, and the degree of the order is also 1. Therefore, this equation is a linear equation. There, and the classification of this equation is it is a first order linear ordinary equation. And to prove as an exact equation, we need to rewrite again the given equation. So this one. So to first to solve the exact equation, we need to prove this as an exact. So to do that, we need to convert this to the standard form of exact equation. So to do that, we need to um, multiply both sides by dx, and that will give us this one's going to be cancelled out, and the y should be transferred to the other side of the equation, and that will give us this one. After that, we need to let the dx and the dy as m of x and the x dy as n of xy. And after that, we need to differentiate those terms. So first, we need to differentiate the m of xy in terms of y, and that will give us 1 since there is only one y here. And the differential of n xy with respect to x, or in terms of x, that will give us 1. Therefore, this we have proven that this equation is an exact. So to solve for the exact equation, we need to take the m of xy and integrate it with respect to dx. That will this one. That will give us this one. After that, to solve for the h of y, we need to differentiate this result with respect to y, and that will give us x plus h y prime y, since there's only one y here, this one. So to solve for the hy, we need to equate this to our n of x, xy, and that will give us this one. So if we're going to transpose either of these variable x, it will be cancelled out. So to solve for h prime of y, or hy, we're just going to integrate both sides. So h prime of y equals to 0, integrate both sides will give us hy equals to c. And after that, to solve for the exact equation, we're just going to plug in the value for the hy, and that will give us this one. And this one will be the exact equation. So to solve for the general solution, we need to solve for the y. So we're going to transpose the right side to the left, but not including the xy, and that will distort this one. So to solve for the general equation, or to solve for y, we're just going to divide both sides by x, and that will give us this one. So this will be the general equation in exact by using the exact equation. So proceeding to number 3, we're going to rewrite again in this will be in linear equation. So we need to convert this into the linear equation, the standard form. So to do that, we need to divide both sides by 1 over x. So this one will cancel out, and we need to transpose the y into the left side of the equation, and that will give us this equation. So after that, we need to identify our p of x, which is 1 over x, this one. And also, we need to solve for the integrating factor, which is simply e to the integral of the p of x with respect to x, and that will equal to x. So our integrating factor is x. After that, we need to multiply the integrating factor to the each term of our equation. So that will give us this one. And after that, the left side of the equation will be equal to the the product the differential of the product of the integrating factor and y. That will give us this one. So to solve for the general equation, we need to integrate both sides. And this one will still remain as xy, since this will be cancelled out. And this one will be given by this one. So to solve for the general equation, simply we're just going to divide the equation by x, so that y will remain, and the general equation will be this one. So as you can see, both of them are equal. That only means that our equation is correct, since both of the exact equation and linear equation type of solving the solution or the general solution of the given equation is correct.